Fourth grade into math lesson 17.3. Identify and classify triangles by sides. I can describe the differences between an equilateral, isosceles, and scalene triangle. So yesterday, when we were doing our labeling of different triangles, we were looking at their angles, right? Okay. Today, we're going to look at their sides to help us determine what type of triangle we have in these different areas. Okay. Step it out. Number 1, a team of solar engineers is researching triangular solar panel designs. These are 3 of the design options. How can you classify triangles? By their side lengths. Okay, so we would get a centimeter ruler and measure the lengths of the sides of each triangle. Okay, so they want us to measure line BC first, and, or segment BC first, and so you're going to put your 0 on your ruler right here at B, and then figure out how long it goes from B to C. Can anybody tell me what that is? 3 centimeters. Okay, now you're going to put 0 over here at C and measure out to D. What is that? 4 centimeters. And then DB, so now we're doing this line right here. Can somebody tell me what that is? 5 centimeters. Okay, we're going to do JK. So right here, put 0 on one of those points and then measure to the other end. 3 centimeters. Okay. How about KL? So right here, 3 centimeters. And then what about JL? 3 centimeters. Now, as you look at this, we have 3 different sizes for the first triangle. And does that look about right? Like it looks like they might be 3 different sizes. Okay. And then for this middle one, they were all the same size. Does it look like those are all congruent? Okay. So, kind of what your perception is that matching what our what we're doing for our measurement? Yes. Okay. All right. So they want QR first. So right here, QR. What's that? 3 centimeters. RS, though, right here. 4 centimeters. And then SQ. 4 centimeters. Okay. So they're saying 2 of those sides are congruent, and then the bottom is not. Okay, so they also give a vocabulary lesson over on this side. An equilateral triangle has 3 sides of equal length. So if I flip my page back over to the front, which one of these would be an equilateral triangle? The first, the second, or the third? The second. This one would be equilateral. Remember, what I do, you do. Okay. Then an isosceles triangle has at least 2 sides of equal length. So which one would be the isosceles, the first or the last? The last. Okay. And then we have a scalene triangle. It has no sides of equal length. So that would have been the first one. Okay. So use connected vocabulary to help you identify and record an example of each triangle from your classroom. Okay, so we went ahead and talked about letter A together. Letter B, identify and classify the triangle, right? Equilateral, isosceles, or scalene. So let's say, real quick, equilateral has to have how many equal sides? 3, right? Isosceles has to have how many equal sides? 2, and the scalene has none, right? Okay, so let's measure this with our ruler. What is the measure of AC? 3 centimeters. Okay, so I'm going to write 3 centimeters right here. What's the measure of CB? Okay. Is it 2 or 2.5? Okay, so 2 centimeters. And what is the measure of AB? Okay, so 2 centimeters. So, is that going to be equilateral, isosceles, or scalene? Isosceles, because it has 2 congruent sides. Okay, next triangle. What is the measure of FD? 3. Okay. What is the measure of DE? 2. And what is the measure of FE? 4.5. So I'm just going to put 4.5 centimeters. Okay. What type of triangle is that? Does it have any congruent? No. So it's a scalene. Okay. And then how about GI? 2.5. Okay. So 2.5 centimeters. Okay. What about GH? 2.5. Okay, or 2.5. And then what about IH? 2.5 centimeters. Okay, so all of those are congruent, so that's an equilateral. So when I was naming those, I should have said, what does the little symbol out front mean? Right here. Triangle ABC, right? This was triangle DEF, and then this, of course, was triangle GHI, right? Okay, and then we named what type of triangle they were. Understanding, identify and classify the triangle, right? Equilateral, isosceles, or scalene. Use a centimeter ruler and read it. Okay, so just looking at number 1, what type of triangle do you think triangle KJL is? Okay, I hear isosceles and I hear scalene. Okay, so either scalene that none of the sides are equal, or only or isosceles that 2 of them are. Let's use our centimeter ruler to check and see what that is. Okay, so what is the measure of KJ? KJ is 3.5. Okay, so 1.5 centimeters. What is KL? 3.5. 4. And what is JL? 3.5. Okay, hold on, let me look. Okay, so on further inspection, KL is 4.5 centimeters and JL is 4 centimeters. Now, remember, when you use your ruler, you can't just go with the very edge of the ruler because that is not where 0 starts. And if you are using that, then that's going to get you a little bit off on your measurement and then maybe not the right answer. Okay, so you have to line it up with the first mark on your ruler to classify it as 0. Okay, so are any of these sides equal? No. What did we forget to do in the directions before we started? An equilateral has how many equal sides? 3. Isosceles has 2, and a scalene has 0. So which one is it? A scalene. Okay, just looking at number 2, what type of triangle do you think that is? And why would that be a quadrilateral? A quadrilateral has how many sides? 4. We're talking about triangles. Is quadrilateral even a choice for our answer? No. So make sure you guys pay really close attention to that. So to me, all those sides look what? Equal. Okay, let's use our ruler to check. So what is ST? 2.5. So 2.5 centimeters. What is TU? 2.5 centimeters. And what is SU? 2.5 centimeters. So were we right? Okay, so equilateral. Okay. Looking at number 3, just looking at it, what type of triangle do you think that is? Isosceles, maybe? Okay, take your ruler. Let's see what is X, Y. Okay, so when we look at that, we have our centimeter marking, but then we have all those little tap marks in between. How many millimeters are there in a centimeter? 10. Do we know our decimal place up to 10? Yes. So can we go ahead and write that in a decimal form? So can we go ahead and write 2 7/10 of a centimeter? Yes. Okay. What about over here for YZ? Same thing, right? 2 7/10 of a centimeter. What is XZ? 3.5. So 3 5/10 centimeter. So what is my answer for number 3? What type of triangle? Isosceles. On your own, number 4, use the solar panel and centimeter ruler. Measure the side lengths of the yellow triangle. How can you classify the yellow triangle? So what is this measurement right here? What's the left side? So I can take your ruler and measure it. 4. Okay. What's the measurement of the right side? Okay. And what's the measurement of the bottom? So what type of triangle is that? Is it equilateral? Equilateral has to have how many? All of them. Are they all equal? No. Isosceles has to have 2. Are there 2 sides equal? Yes. Okay, so isosceles triangle. Okay, identify and classify the triangle. Use or write equilateral. How many sides? Has to be equal? 3. Isosceles? 2. Scalene? 0. Use a centimeter ruler if needed. So just looking at number 5, what do you guys think? Okay, let's get our rulers and double check. So what'd you get for JL? 3.5 centimeters. What about JK? And then what about LK? Okay, so it's a what type? Equilateral. Okay, what do you guys think about number 6? Isosceles. Okay, let's take our centimeter ruler and check. For isosceles, it has to have 2 equal sides. Okay, well, let's check. So what do you guys think for MO? Okay, what about MN? Did you all get 3.5 for MN? Okay, so like I said, you have to pay very close attention to those little tap marks. Can you literally just say that they're even though they're not right on the line? No, okay, because if you do that, you're not going to get the right answer. Because you can tell looking at this that these are not all the same length, okay? So this side is 3.6 centimeters, and this side is 3.4 centimeters. Now, are those super close? Yes. But do those 2 millimeter difference, does that make a difference? Yes, it does. Okay. How long is ON? 2 centimeters. Okay. So what type of triangle is that? Scalene. Like I said, you can pretty well see that by looking at it, but when you go to measure, you have to be precise and not just do an about. All right? Measurement.